Today we'll be working on the following problem. Let D be a subset of a closed unit interval, and D is Lebesgue measurable with the Lebesgue measure 0. Is D necessarily meager? So if E is a subset of 0, 1, the E is a meager set. Is E necessarily having Lebesgue measure 0? So pause the video if you want to work on this problem by yourself. Okay, let's see what is the answer for that. Solution. First, let's recall what is the definition for a set to be meager. So because here we're using the Euclidean matrix defined in the interval from 0 to 1, right? So A is meager. A set A is meager in any topological space. In our case, it's a metric space, right? A is meager if A can be written as the union of set A sub n, where each A sub n is nowhere dense. Right? This is definition for a set to be meager. So let's try to construct D and E, so to see if they must have the property or not, right? So if we recall let's use this like a recall solution to problem 22, where if you go back to the solution to 22, you can see where we have proved like for any epsilon between 0 and 1, there exists open set, let's see, U sub epsilon in the interval such that the Lebesgue measure of this open set is epsilon, and then the closure of this open set is the closed unit interval. So this is to say like U sub epsilon is dense in 0, 1, right? So we can let let epsilon be 1 over n. So we apply this like so we can have for any n greater than 1, we can have C sub n, which is defined to be the complement of this open set defined with 1 sub n, right? So this set, because this is dense, right? U sub 1 over n is dense, so C sub n is nowhere dense. Nowhere dense in here. And then the measure of C sub n is what? Because the measure of U sub n 1 over n is 1 over n. So this is 1 minus 1 over n, right? So we already find a subset of 0, 1, which is nowhere dense. So Cn, so in other words, Cn is meager, right? By the definition, is meager. So we have Cn is meager, but the Lebesgue measure of Cn is greater than 0, right? So the answer to our second question of the problem is negative. So we can let any E to pick this one of the Cn's, right? So now we have so now let's see the answer for the first one. If we let C equals to we uni all the C sub n. So because each C sub n is nowhere dense and it's countable uni, so C is meager. And then what is the measure of C? The C clearly is greater than the measure of each C sub n, right? And then which is 1 minus 1 over n for any n. So that n goes to infinity, we give m's, the measure of C is 1. Because this is at most 1, right? So we have the measure of that. Now that D is the complement of C in the closed unit interval D. Then this D, because of the measure of C is 1, so the measure of D is 0. But by Bayer category theorem, we know because C is meager, and then the closed unit interval regarded as a metric, using the Euclidean matrix is a metric space and it's complete metric space. So it is of this guy, this is of second category, right? From Bayer's category theorem. So D is non-meager. D is a non-meager set. And then D is a non-meager set with Lebesgue measure 0. So the answer to the first question of this problem is also negative. Right? That's it.